Hi and welcome, and we're going to do the lesson today on states of matter and changes of state. Your Pearson Realized textbook, chapter 12, pages 441 to 453. The vocabulary words that we're going to use in this lesson are matter, atoms, states of matter, solid, liquid, gas, thermal energy, and kinetic energy. Let's go through some definitions. First of all, matter is in a substance that has mass and takes up space. The smallest unit of matter are called atoms, which are the basic units of matter. Why does a substance change? We describe the changing states of matter as physical characteristics of the atoms and molecules, the arrangement of atoms and molecules, and the amount of thermal energy absorbed by a substance. When we do look at the states of matter, we classify it by the change of state. This arrow in this diagram will represent the change of state. This is an ice cube. It's a solid, and it can change to a liquid. A liquid can change back to a solid. Over here is a gas. A gas can change to a liquid, and a liquid can change back to a gas. Now here's another way that it can change. It can change directly straight to a gas. Shapes are how close the particles are, and we ask ourselves the question when we look at shape, how close are the particles? And is the shape definite? Volume is how much matter takes up the space. So we ask ourselves, can the volume be measured? And is the volume definite? This chart here will help us to better organize the difference between each state of matter. So we're going to describe each state of matter. The first one is a solid, and in this chart we have over here shape and volume, and on the top of the chart we have definite or indefinite, and this is a picture or a model of the particles of a solid. For the solid, both definite for shape and definite for volume are checked. Same thing over here for liquid. We have shape and volume, and then we have definite, indefinite, and here's the particles of a liquid. For shape, we have indefinite checked because it can depend on the shape of the container, and the volume, we can definitely measure it. A gas for shape and volume, both indefinite are checked. Here's what the particles of a gas look like. Now here it is as a phase change diagram. Along the x-axis, I have the term heat energy, and along the y-axis, we have it labeled as temperature. We have this for our slope, and it's a changing slope because phase changes depending on how much heat energy is put into it. Here we have the letters A, and we have a slope rising line, and I put a little model of a solid, and then B at the corner, and from here it is a flat horizontal line, and I have melting going to left to right and freezing going right to left. And then I have the C in this corner. Then I have the diagram model of a liquid, and it's kind of scattered, spread out because there's more energy as it transitions over here. I have D in this corner. You can have vaporization going this way because it's an increase, and condensation reducing heat energy that way, and E in the corner, and then a model of the gas, and F up here. And as you can see, as heat energy is into the substance, then it goes more spread out and the molecules are moving. As you reduce the heat energy, then you have the molecules changing shape, and it can change the phase. Do molecules have energy or atoms? Oh, I have a couple of notes for you. The movement of molecules or atoms is kinetic energy. The average kinetic energy of molecules is a measurement of the molecular motion. And as the temperature rises, the average kinetic energy of the molecules will increase. And here I have a model of the arrow showing how much energy it's moving and the kinetic energy. on average for a lower temperature versus higher temperature, the more movement it will have. Thank you so much for your attention, and I hope that you did very well. If not, please ask me questions.